Hi everyone, this is Mr. West. I'm doing today what we would call a Kuta, imaginary and complex numbers practice. You can't see me doing it, but I'm doing quotations with my fingers because this really isn't a Kuta, but this is a good worksheet that a teacher might print off for you. So let's talk about imaginary numbers. What are they? Imaginary numbers here are how we rationalize something, how we simplify something if we have a negative radical, okay? Obviously, we know that if we multiply a negative times a negative, it equals a positive. So what could we multiply together twice to get a negative number? Nothing. That's why we come up with an imaginary number, deemed the lowercase I. So this is the equivalent expression here. Square root of negative 1 is equal to I. So we have to deal with imaginary numbers here because there is no such real number where this is true. Now, we can have all different variations of I squared, I cubed. For this exercise, I'm only going to need I squared. So I have negative 1, square root of negative 1 times the square root of negative 1. What would that be equal to? Well, that's the same thing as I times I, okay? So those two are equivalent, okay? Because we already know that square root of negative 1 is equal to I. Or we could recognize that if we have a square root times itself, okay, we know that's going to equal just whatever's underneath the radical. So in this case, it's negative 1. Okay, square root of negative 1 times square root of negative 1 is going to give us negative 1. I squared is going to be equal to negative 1. So that's really the breakdown here of what we need. And just as a clarification, here we go. I just wanted to do, oops, I forgot that squared. I squared. Let me get that in there. Okay, just as a clarification, if we have like square root of 4 times the square root of 4, it's going to equal 4. Okay, so whatever you multiply underneath the radical by itself, it's just going to equal underneath the radical. Okay, for this one, for this video, I'm gonna just do these problems over here. And if you need a part 2 for my requester, George, let me know and I'll make another video for you. But in this case, I'm gonna switch colors here. Let's go to purple. So here we have square root of negative 16. We would know square root of 16 by itself. That's easy, that's 4, but now we have that negative in there, and we're going to have to deal with some imaginary numbers. Anytime you have a radical like this, each radical you got to break down into its imaginary components and its regular rational components. So we have square root of 16. I'm going to separate that, and then I'm going to put this square root of negative 1 over to the right next to it. Okay, so each one, we're going to do it separately. We know this is equal to square root of 16 is 4. That's a perfect square. And then we know that we can rewrite the square root of negative 1 as I. Okay, so that is rewritten as I, and this is the simplified form right here. 4I. I'm going to make it a little bit smaller. I don't know why I'm writing so thick. So we have 4I for our answer there. Okay, so moving on to square root of negative 8. Okay, same process. I like to split up this negative number into its positive components. So in this case, square root of 8, and also its negative components. You have to do this for each radical, okay? So square root of 8, and then we have square root of negative 1. Now, what do we get when we do that? Well, we have square root of 8 can be broken down to square root of 4 times square root of 2, and I picked 4 because that's a perfect square. And then I would rewrite square root of negative 1 over here, okay? And I'm highlighting that because we need to change that eventually. Square root of 4 we know is 2. And then square root of 2 cannot be simplified. And then we have square root of negative 1, which we know as I. Anytime I get an I like this, I don't like to write it after the radical because sometimes as you're writing your math, it's unclear if it's underneath the radical or not. So I always move it to the front with the number out front. Okay, that way it's very clear that only that 2 is underneath the radical, and then we have 2I out front. And that's going to be our final answer there. This one's a little tricky, okay? If you were to just apply your normal rules for radicals, okay, there's two different things we could do here, okay? First thing, we could apply our normal rule. Square root of a root times a root is just the number underneath the root, so we get negative 6, okay? On the flip side, imagine if you multiply the square root of negative 6 times the square root of negative 6, and you just wanted to multiply those two together. Negative 6 times negative 6 equals 36, a positive, because we know negative times negative equals a positive. And then we keep the radical, we get positive 6. There's a discrepancy there. Okay, and it just so happens you can't multiply these together until you've simplified the imaginary components first. You can't do that. Otherwise, you're going to get two different answers. So let me X this out here. Can't do it. Pause your screen. Take that note if you want, but I'm going to erase it so we can show you the imaginary way to do that. Okay, so now that we know we need to handle each radical as it comes with its imaginary components, we're going to write -6. Okay, sorry. I take it back. We have the positive component of this first one, 6 times the square root of -1, times the next one, square root of 6, times the negative component, square root of -1. You're going to see we get a different answer here as we treat each imaginary number as it comes in the radicals, okay? So we have square root of 6, okay, can't do anything with that, but we have this square root of -1 times this square root of -1. We can rewrite this as I, or we can write this one as I, or not or, and. Now, two different things we can do here. We can either multiply the -1 times the square root of -1, and what do we get? When we have a radical times a radical, it undoes the radical, and we just get what's left underneath. Okay, so in this case, square root of -1 times square root of -1 equals -1, and we'd still have the square root of 6 times the square root of 6, which we know is 6. Square root of 36 equals 6. In this case, we'd get -1 times 6, -6. So you see we get a different answer when we break it down into its components. Okay, now let's use the I method. Here we have I squared of, whoops, wrong pen, I squared of 6 times I squared of 6. Okay, what happens here? Well, this is rewritten as I squared, square root of 36. We know up here that I squared is the same thing as -1. Okay, and notice how it escaped the radical. Okay, it escapes the radical. We have to handle each one as it comes. And this I squared is on the outside now, which we know is -1. And then we know square root of 36 is 6. We get the same thing. So you have to treat each negative radical, negative root as it comes. Okay. Next up, we have 4 plus, and then in this case, it's actually going to be pretty easy. We have square root of 25 times the square root of -1. Remember, separate the positive and negative component with each radical. So we have 4 plus 5, okay, but we still have the I attachment because it's 5 times the square root of -1, which is I. And then this is our final answer because it's a complex number and we can't break it down any further than this. You can't combine those unlike terms. Last one we're going to do today, unless you need another video, let me know. We have 6 minus, okay, and we already know what this is equal to, but I'll do it again. We have square root of 8 times the square root of -1 all over -2, okay? So we have 6 minus square root of 4 times square root of 2 times square root of -1. I'm going to write it as I right away. Okay, so this is I over -2. So then we have 6 minus 2I. I like to write it next to each other. There's the I. Okay, so it's not confused with the root, which is there, over -2. And this is a minus right here. Now, because this is minus, okay, I need to apply this divide by -2 to both terms in the numerator. So this term and this term. I have to apply it to both of those. So let me separate it. I'm going to separate it in blue. So we have 6 divided by -2 minus 2I square root of 2 over -2. Okay? So I have 6 divided by -2. That's going to give me a -3. And then I have a negative over a negative. That's going to be a positive. And I'm going to divide the 2's. Those are going to cancel away. I'm left with I radical 2. And that's my final answer. I could also write it as I radical 2 minus 3. But the real part really should go first. So I would just stick with your first answer, which is that. Okay, that was a brief explanation. If you need more, I can go over more with this. You leave a comment if you want some of these exercises done. Pause your screen there. But anyway, that's a quick wrap up of this Kuta, in quotations, imaginary and complex numbers practice. Hope you see you next time right here on West Explains Best.